My name is Vineeth. I'm the AI researcher at Cisco. Today I'm going to talk about the ANS protocol that Ken and I and our co-authors Idan and Akram released, which is now being deployed by a few companies. So super exciting. So yeah, the goal for ANS was is basically like creating a universal discovery system to enable like scalable communication between autonomous AI agents across the internet, right? If within your enterprise you can always create your private registry and it's much easier, but across the entire open web becomes a lot more complicated. So why ANS matters, right? So like agents have been the number of agents have been increasing. Initially, when LLMs were just part, chat box, they didn't have much agency. They didn't have tool use. They were like pretty isolated. But now with we giving agents access to like a lot of permissions, we're giving them access to a lot of agency. How many of you have seen Replit deleting the entire database of a company, right? So like we are giving a lot more permissions and privileges to agents. And the need for ANS is we don't want to create fragmentation. We want to create a universal directory so every agent can find each other and talk to each other. Irrespective of the protocol, it's better if we can create a universal directory so we don't create, pockets or walled gardens within the industry. So what is ANS, right? So ANS stands for Agent Name Service. It's a protocol-agnostic directory service inspired by DNS. So that's the naming scheme. So we piggybacked off DNS. Why reinvent the wheel when it already exists? And so it also assigns like structured names to AI agents, which I'll show you in the following slides. It encodes their identity, which is like the agent capability as a top layer, as a top level part of the I guess domain, and version in a standardized format. It has seamless interoperability. It also can support MCP tools, so it's not just for agents; it can be for agentic tools as well. So yeah, this is the naming structure that I was telling you guys about. So you have the protocol. It can be A2A, ACP, MCP. The reason we made it agnostic initially is because we don't know what protocol is going to win out in 3 to 5 years, right? We don't want to like hone in on one protocol now and then later like have to backtrack. And the agent ID is just the unique name for the agent ID. The capability is it's possible you have one agent that can do many things, but when you are looking for an agent, you're searching semantically or you're looking up specifically, it's good to tie down to what specific identity of that agent you are trying to reach out to, right? Let's say you have identity capability can be like text processing, it can be summarization, it can be like anything and so on, right? Provider is which enterprise or company is providing this agent. It can be like Google, Microsoft, any company, for example. You have the standardized version format, and then you have extensions, right? Extensions can be like compliance based extensions like HIPAA, GDPR, and so on. So this is the ANS naming structure. So some of the core innovations are is cryptographic identity verification, right? So we piggyback off PKI. So we cryptographically verify the digital signature that we mint to each of the agent. We have lifecycle management, right? So when the registration happens, we use PKI for minting the certificates, renewing it, expiry process, and maintaining like up to date, including CRLs, certificate revocation lists, and so on. It's a secure directory. That means you can also like use ANS to search for agents, as well as like resolve agents. You can also search semantically, because it's capability aware. We're not just going by names. We can also piggyback on like some of the wins of DNS, like DNSSEC, and also URLs, right? So we can look for like agent spoofing or agent card spoofing, and a lot of other things can be taken care of with ANS. So at a high level, this is the architecture, right? So initially you have your agent registration. So the agent registers with the registry. Again, you have a public-private key. All of your capabilities are, like initially we thought about making it a lot more hands-on, where we like verify the capabilities and everything, but it's like a difficult tug of war between making it as open and easy to register versus like verifying everything. So do you want to go the route of like an Apple store where Apple verifies every app like very thoroughly, or do you want to go with like websites as anyone can create a website? So it's those are the two different ends, and we chose somewhere in between, and we want the community to decide where this would go. I'm not going to talk about the certificate issuance and protocol because I've already spoken about it. The protocol adapters is a really cool part where we have adapters in place for cross agent communication. So A2A can initially talk to ACP, and at least in the beginning, because like I said, in the future we might have one dominant protocol. So up until then, we wanted a protocol architecture, and then you have your resolution framework. So, and finally, what is the real world impact, right? When we initially conceived this idea, our goal was a lot more altruistic, is to make it as interoperable and as open as possible without creating walled gardens for any one protocol. And so, yeah, this will enable secure AI marketplace and enterprise automation. And finally, my last slide is, now that we have AI agents, next is agentic commerce. There's a lot of research that we're doing in this space. So, feel free to reach out to me at any time to talk about any of these. Thank you so much.